Dear friends, in this class, let us discuss about Euler number. So what is an Euler's number? Euler's number is usually denoted by E, and it is stated as a mathematical constant. Its value is 2.7182, 2.7182, etc. Means E always lies in between 2 and 3. So E is stated as a mathematical constant. And there is nothing but a sequence. The sequence En equals sequence 1 plus 1 by n all power n. En equals limit. So that is a limit of this one. 1 plus, consider the sequence En. So En equals limit of 1 plus 1 by n all power n. So this, what is 1 plus 1 by n all power n? By binomial expansion, it is 1 plus nc1 into 1 by n. What is nc1? 1. So nc1 n into 1 by n. So it is again 1 plus nc2. What is nc2? n into n minus 1 divided by 1 into 2 means 2 factorial into 1 by n square plus next is n into nc3, n into n minus 1 into n minus 2 by 3 factorial into 1 by n cube plus etc. plus what is the last term? Last term is 1 by n power n. So that equals, it is 1 plus then take n commonly outside. So it is n square and n square cancelling each other. That is n square into 1 minus 1 by n by 2 factorial into 1 by n square plus etc. plus 1 by n power n. So that equals 1 plus this n square cancelling. So it is 1 minus 1 by n by 2 factorial plus the next time is 1 minus 1 by n into. So 1 minus 2 by n divided by 3 factorial plus etc. plus 1 by n power n. So what is en plus 1? En plus 1 equals, this is en. So en plus 1 equals 1 plus 1 minus 1 by n plus 1 by 2 factorial plus 1 minus 1 by n plus 1 into 1 minus 2 by n plus 1 by 3 factorial plus etc. plus 1 by n plus 1 or power n plus 1. Surely that means En strictly, that is En strictly less than En plus 1 for all n following n. That means sequence En is monotonically increasing sequence. Sequence En is monotonically increasing. Now, what about the boundaries of this En? Also we have 2 strictly En equals limit to 1 plus 1 by n all power n. Then also we have En strictly less than 2. En strictly less than 2. En equals limit to 1 plus 1 by n all power n. So we have 2 strictly less than En. Now again, for p equals 1, 2, etc. to n, we have 1 less than p by n strictly less than 1. When p equals 1, 2, etc. to n, surely 1 less than p by n strictly less than 1 for all n. Therefore, according to this argument, what is En? En strictly less than 1 plus 1 by 2 factorial plus 1 by 3 factorial plus etc. plus 1 by n factorial. Also we have, what is 2 power p minus 1? 2 power p minus 1 less than or equals p factorial. For p equals 1, 2, etc. to n. So 2 power p minus 1 less than or equals p factorial means 1 by p factorial less than or equals 1 by 2 power p minus 1 for p equals 1, 2, etc. to n. Okay. So from this relation, what I get? Therefore, En strictly less than Suppose it is 1. Therefore, 1 gives En strictly less than 1 plus 1 plus 1 by 2 factorial. 1 by p factorial less than or equals 1 by 2 power p minus 1. It is true for p equals 1 to n. So it is 1 by 2 factorial. It is less than 1 by 2 power 2 minus 1. 1 by p factorial 2 power p minus 1. So it is 1 by 2 power 2 minus 1. Plus 1 by 3 factorial. It is less than 1 by 2 power 3 minus 1. Plus etc. Plus 1 by n factorial. It is 1 less than or equals 1 by 2 power n minus 1. That means this equals 1 plus 1 plus, so it is 1 plus 1, that is 2, so it is 2 plus 1 by 2 plus 1 by 2 square plus etc. plus 1 by 2 power n minus 1. Okay. So that equals 2 plus, what about this one? 1 by 2 plus 1 by 2 square plus etc. plus 1 by 2 power n minus 1. That is nothing but a geometric progression. It is a geometric progression with a common ratio 1 by 2, having first term is 1, or this is 1 plus. Instead of this one, it is 1 plus this one. So it is a 1 plus 1 minus 1 by 2. It is equals 1 plus 1 plus 1 minus 1 by 2 all power n divided by 1 minus 1 by 2. Why? Because the term inside this bracket is nothing but a geometric progression having first term 1, common ratio r equals 1 by 2, strictly less than 1. Hence, the sum of the first n terms is a into 1 minus r power n by 1 minus r, that equals 1 plus 2 into 1 minus 1 by 2 power n. Means it is strictly less than 3. Therefore, the value of En, En strictly less than 3 means it is bounded. That means sequence En is bounded, and we also see that it is an increasing sequence. Then by monotone convergence theorem, it is convergent. So the value of En is converged to a real number. That means it lies in between 2 and 3. So this E is known as Euler's number. Its value is 2.718 etc. It's an anonymous quantity, and E is treated as a mathematical constant. And that's the sequence. That is En equals, the sequence is 1 plus 1 by n all power n. Its limiting value is En. So En equals, or simply E equals, En instead of n. E equals limit 1 plus 1 by n all power n. So finally, you can conclude that what is E? The limit of the sequence 1 plus 1 by n all power n means limit n tends to infinity, 1 plus 1 by n all power n equals E. So this is the Euler's number. Agree? So what about the limit of 1 plus 1 by n all power n plus 1? According to this argument, we have limit n tends to infinity, 1 plus 1 by n all power n equals E. Now, calculate the limit of this sequence, 1 plus 1 by n all power n plus 1. What's the limit? That equals limit 1 plus 1 by n all power n plus 1 can be rewritten as 1 plus 1 by n all power n into 1 plus 1 by n. Okay. By the property of limit, it is limit 1 plus 1 by n all power n into limit 1 plus 1 by n. So we see that limit 1 plus 1 by n all power n is nothing but E. So it is E into, what about the limit of 1 plus 1 by n? When n tends to infinity, it should be 1. So the value is E itself. So limit n tends to infinity, 1 plus 1 by n plus all power n plus 1 is E. Means the limit of this sequence, 1 plus 1 by n all power n plus 1 is E itself. Okay. What about the limit of 1 plus 1 by n all power 2n? This is nothing but limit 1 plus 1 by n all power 2n means n square. That is limit 1 plus 1 by n all power n into, limit 1 plus 1 by n all power n into 1 plus 1 by n all power n. Okay. So by the property of limit of this one into limit of this one, what is limit of 1 plus 1 by n all power n? E. So E into E. So the required limit is E square. Enough. It means limit of n tends to n or limit of the sequence 1 plus 1 by n all power 2n means 1 plus 1 by n power n whole square. So its limit is E square. What about limit of 1 plus 1 by n all power 3n? It is limit of 1 plus 1 by n all power n whole cube. So its limit means that converges to the point E cube. Agreed? So what is limit 1 plus 1 by n? What is the limiting value of the sequence 1 plus 1 by n plus 1 all power n? 1 plus 1 by n plus 1. Come to the standard form. Euler number means limit 1 plus 1 by n all power n equals E. But find out limit of 1 plus 1 by n plus 1 all power n. So how? You consider 1 plus 1 by n all power n. 1 by n plus 1 all power n. 1 plus 1 by n plus 1 all power n equals, this can be rewritten as 1 plus 1 by n plus 1 all power n plus 1 divided by 1 plus 1 by n plus 1. Okay, you can introduce 1 plus 1 by n plus 1 on numerator simultaneously on denominator. So it is 1 plus 1 by n plus 1 all power n plus 1 by 1 plus 1 by n plus 1. Now listen, what about the numerator? Numerator sequence 1 plus 1 by n plus 1 all power n plus 1. So this is the term in the numerator. So consider the sequence 1 plus 1 by n plus 1 all power n plus 1. This is nothing but a one tail. This is nothing but a one tail of the sequence 1 plus 1 by n all power n. We already discussed about the m tail of a sequence. What is the m tail of a sequence? M tail of a sequence x equals xm plus n. The sequence xm plus n is known as the m tail of the sequence xn. That is where n equals m equals 1, 2, 3, etc. xn plus 1, xn plus 2, etc. be the m tail sequence. So m tail sequence of x is xm plus n. So the 1 plus 1 by n plus 1 all power n plus 1 is nothing but the one tail sequence of 1 plus 1 by n all power n. And we also proved that. We already proved that when a sequence converges to x, then its m tail sequence also converges to same value. Here limit 1 plus 1 by n all power n converges to e. Therefore limit 1 plus 1 by n plus 1 also converges to e itself. Agreed. So its limiting value is the numerator converges to e according to this argument. So this e by, what about the limit of this one? That is 1. So the limit of 1 plus 1 by n plus 1 all power n is nothing but e itself by using the convergence of m tail of a sequence. Enough. Okay. What about the limit of or the convergence? That's the convergence of the limit 1 minus 1 by n all power n. Here we have a standard result 1 plus 1 by n all power n always converges to e. What about 1 minus 1 by n all power n? So suppose we have let xn equals, what is xn? Xn equals 1 minus 1 by n all power n. That means it is n minus 1 by n all power n. N minus 1 by n all power n. That is xn equals 1 by n minus 1 all power n. Agreed? 1 by n minus 1 all power n. That can be rewritten as 1 by, it is n minus 1 plus 1 by n minus 1 all power. You can introduce minus 1 and plus 1 on numerator. That is 1 by n minus 1 plus 1 by n minus 1 all power. That equals, it is 1 by term division, it is 1 plus 1 by n minus 1 all power n. Agreed. Now what about 1 plus 1 by n minus 1 all power n. So, or this can be again rearranged as 1 by 1 plus 1 by n minus 1 all power n minus 1 into 1 plus 1 by n minus 1. Enough. So that means xn equals 1 by 1 plus n minus 1 all power n minus 1 into 1 by 1 plus 1 by n minus 1. So consider the first step. That is nothing but a one-tail sequence. One-tail sequence of is 1 plus 1 by n minus 1 all power n minus 1 is 1 plus is 1 by 1 plus 1 by n minus 1 all power n minus 1. Now consider 1 plus 1 by n all power n. This 1 plus 1 by n all power n is a one-tail sequence of 1 plus 1 by n minus 1 all power n minus 1. Here 1 plus 1 by n minus 1 all power n minus 1. So 1 plus 1 by n all power n is nothing but a one-tail sequence of 1 plus 1 by n minus 1 all power n minus 1. We see that 1 plus 1 by n all power n converges to e. So its one-tail sequence also converges to e. So it equals 1 by e into, what about the limit of the second term? That is 1. So limit 1 minus 1 by n all power n, or the sequence 1 minus 1 by n all power n converges to 1 by e. This is again, here we use the result of that. When a sequence converges to x, then its m-tail sequence also converges to the same value. Okay, now let us discuss the subsequence of a sequence. What is a subsequence? So subsequence means, suppose x is any sequence, x equals xn is a sequence of real numbers. X equals xn be a sequence of real numbers. If n1 less than n2 less than etc less than nk less than etc be a sequence of natural numbers, then sequence xnk is said to be a subsequence of the sequence xn. Let x equals xn be a sequence of real numbers. If n1 less than n2 less than etc less than nk less than etc be a sequence of natural numbers, all of these ni fall in n, sequence of natural numbers, then the sequence xnk, this denoted by some x dash, sequence xnk is said to be a subsequence of the given sequence x. Okay. So for example, you consider the sequence xn equals 1, 1 by 2, 1 by 3, 1 by 4, etc. Consider this sequence 1, 1 by 2, 1 by 3, 1 by 4, etc. Now we choose that n1 equals 2, n2 equals 4, n3 equals 6, etc. Clearly n1 less than, n2 less than, n3 less than, etc. All of these ni's are natural numbers. So what about here xnk? Here xnk equals n1 means, n1 equals 2. So xn2, the second term, 1 by 2, next is 1 by 4, next is 1 by 6, etc. So clearly xnk be a subsequence of x. Xnk be a subsequence of x. Okay, so this is a subsequence. For another one, suppose consider again a sequence xn equals 1, 2, 3, 4, 5, etc. Here we choose n1 equals 1, n2 equals 3, n3 equals 5, etc. So what is the subsequence? The subsequence xnk equals, it is 1, 3, 5, etc. This forms, so xnk is this one. That means xnk forms a subsequence. Xnk forms a subsequence of this x. So this is the subsequences. Means xn is a sequence of real numbers. Therefore, any sequence of increasing sequence of natural numbers, strictly increasing sequence of natural numbers, xnk be a is said to be a subsequence of the given sequence x. Okay. Now, there is an important result. Means the result says that if a sequence converges to a particular point, particular limit, then its subsequence also converges to same limit. A sequence and a subsequence always converges to same limit. So for suppose sequence x equals xn converges to some x. Then by definition, for all epsilon positive, there exists some k following n such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. Agreed. Now in particular, this nk greater than or equals k. For n greater than or equals k, so in particular nk greater than or equals k, this can be rearranged as for all epsilon positive, there exists some k following n such that modulus of xnk minus x strictly less than epsilon, that implies the sequence xnk converges to x. So this is an important result. If a sequence converges to x, then its subsequence also converges to x itself. Means if a sequence and its subsequence converges to same limit. Agreed?